Okay, I think it's now in my hands, sort of, for at least half a minute. So I think probably the most effective thing to do is to just do really quick introductions, so people know who everybody is, and generally speaking, what everybody's working on. And I guess we can just start for this direction, if that works.
Hi, thanks for being here. My name is Dawn Song. I'm a professor in computer science at UC Berkeley, and also the founder and CEO of Oasis Labs. And at Oasis Labs, we are building next generation blockchain smart contract technologies with greater scalability and privacy protection.
Hi, I'm Vitalik. I do Ethereum things.
I'm Kwon. I'm the founder and CEO of Tendermint and the co-founder of COSMOS. We do a lot, but Tendermint is proof of stake. Wait, I was just here, so you guys heard about it, so thank you.
Great, thank you. Yeah, I'm Sergey. I work on Chainlink. Chainlink makes great secure oracles, just to clarify. So I think the first set of questions that I know I and a lot of other people would be interested in, all of you folks have been in this space for a long time, and you've seen it evolve, and I think a lot of you, probably all of you, have clear ideas about where you think it might be going. So I think the first group of questions would probably be around what are the technical developments, the new technologies in your project or other projects, like what are the new innovations that you think are going to help kind of propel our stage to the next, our space to the next stage? Like what are those technical developments? And I'll just start.
Yeah, so as mentioned, one of the main advantages that Oasis network provides is privacy protection. And I think, as everyone here knows, like for example, for many of today's blockchain smart contract platforms, in general, everything is public. There's no privacy protection, but for a lot of applications, they need to handle sensitive data, and hence we need to provide privacy protection for sensitive data and the computation over them. And also, in general, we have seen we are entering the digital age. There's a lot of sensitive data that's being collected. This data either is being siloed, so it's not actually being utilized, or it's being abused, being misused. So there's a great need of technologies that enable users and companies to maintain control of their data and their rights to data, and also at the same time to enable data to be utilized in a privacy-preserving way. So at Oasis Labs, we develop technologies in particular privacy technologies, to help address these problems, to enable data to be utilized in a privacy-preserving way. We use a combination of technologies, including secure hardware as well as cryptographic techniques. And I can talk about one of the new applications that we have done recently. Is I actually just talked a little bit this afternoon. This decentralized French uranium. That's a great use case for this type of technology, where we can enable distributed training of machine models across different users or different devices, and without relying on central trust, so that we can actually, in our case, have a smart contract that actually help coordinate this distributed machine learning in this French uranium setting, but in a decentralized way. And this can help us to enable a lot of new applications. And also, as I mentioned earlier, so for example, with our collaboration with Stanford Hospital, some of the technologies that we have been developing is being utilized for helping patients to contribute their medical data for medical research to enable privacy-preserving certain computation to help find medical treatments.
So So on the privacy side, I've been excited about general purpose zero-knowledge proofs lately. So let's say K-Snarks, K-Starks. There's been some really interesting protocols coming out lately. Like one is called Kwon, there's one called Dark, there's a couple of others. And basically, the thing that's exciting about this is that while we've had things like Snarks for a few years now, there have always been a lot of issues that make them difficult to use. So one, for example, is that Snarks have this kind of per-program trusted setup requirement. So if you make a new application, you have to make your own trusted setup and make this kind of big ceremony where a lot of people come together and generate a key. And like this just really slows down development a lot. And another one is that you just have these different protocols that operate very differently to each other and have very different kind of ways of compiling programs to them. And with these more recent zero-knowledge proof protocols that we're seeing coming out in the last month, like both of those problems basically get solved, right? So in the case of one, for example, instead of there being this trusted setup per program, it's just one trusted setup for the entire protocol. And so basically you have to do this kind of big usage involving a lot of people at once, and after you do it, then anyone can just use the protocol and then you don't need to worry about anything else. And the other is that the versions of different protocols that have different security assumptions are still more similar to each other, and so it's easier to so this is also coming at the same time as we're seeing a big kind of surge in use of general purpose zero-knowledge proofs in general. So Zcash obviously existed for 2 years. In Ethereum ecosystem, there's something called Stark DEX, which is basically using Starks, like the hash-based zero-knowledge proofs, to verify the basically correctness of blocks of transactions that happen inside of a decentralized exchange. And they're working with Coinbase, and they're using this to basically create a version of exchange that does not require trusting the COSMOS party. Another thing is that there's something called Sergey Cash, which is a privacy-preserving mixer on top of Ethereum, which is like running on the mainnet that can be used today. There's another one called Semaphore. There's also infrastructure for things like privacy-preserving voting that's a different vendor development. So you got these months ago, none of these things existed, and now these things are starting to exist, and it feels like there's this really huge jump in the number of interesting things that are happening in space.
And why do you think zero knowledge is taking off now? Is it that the efficiency of how the proofs can get computed has changed? Other than the ceremony, because I know there's been work on getting the ceremony to be more...
I think that there's just been a critical mass of many different things at the same time. One is just the number of people that understand how these systems work. Another is like availability of software. A third is availability of great developer tools. And those are just come all along the way, all in the past year.
Do you see Ethereum going more in this zero-knowledge heavy direction? Is that something that it would support?
At layer 1, no, but at layer 2, the Ethereum Foundation has supported multiple kinds of these privacy-preserving cryptography technologies, and it works closely with people developing them. And they're being used as a platform as we speak.
So, yeah.
No, I just wanted to add to the list of the recent zero-knowledge progress. Also, recently with the work on Virgo, which actually also removes the trusted setup, and it's a new zero-knowledge protocol that's one removes trusted setup and also has performance improvements over previous.
Jay? And you don't need to talk, if you want to talk about privacy, that's fine. The question was actually, what are the significant technical developments that you think are going to shape our space in the next couple of years?
So one thing that's exciting to me is all these consensus, the FG consensus systems, faster finality systems that, starting with Tendermint, but also like hot stuff and so on. And I think that's really important because different consensus algorithms have different properties. And what I want to see the industry going toward, what I think is important, is for us to try to agree on something like ABCI, so that these consensus engines can be swapped for one another. Because I think that will help make everything go faster in terms of innovation and compatibility. And of course, like I mentioned earlier, IBC is the most important thing, in my perspective, for the COSMOS ecosystem and as well as the cryptocurrency ecosystem, in my view, because it's the layer one for scaling. And while I also am excited about zero-knowledge proof systems, what I care about primarily is using as few assumptions as possible in order to achieve scaling, because that's what allows me to sleep at night. And so IBC allowing for interchain scaling and interoperability, I think, is very key. There's a lot of things to still be figured out in terms of what to do with various scenarios and governance that we'll see happening in terms of innovation very soon. And then on top of that, there's all kinds of DeFi things that are very exciting. So in general, like DEXs are interesting, but it's like the Binance DEX, for example, is one way to have a DEX. If you connected a Binance DEX to Cosmos Hub, that's one way to have a decentralized exchange system with no central trusted party. But there are other designs too. There's actually a lot of DEX designs that are coming up. And actually, we're going to also release a paper soon that describes what we think is going to be sort of the thinking framework around how DEXs are designed. It's slightly different than what we've been talking about before. So before we've been saying that there will be a DEX chain connected to the Cosmos Hub. But actually there's a reason to consider alternative models like all the zones being connected to each other and having a decentralized exchange directly between two blockchains. And so we'll publish that paper and describe why we think that's important. And not to say that there's no need for a DEX chain, it's just there are many reasons why you need different kinds of DEXs. And on top of IBC, there's all kinds of things considered like interchain staking. So I think the Cosmos Hub is going to evolve to become, like the Atom token is going to evolve to become an interchain staking token meant for staking in general, so that you can splash bad validator raptors. And that will be exciting to see the Cosmos Hub evolve in that direction. Yeah, so that's what I'm excited about.
Makes sense. And as I look at this panel, I start to see that we've all spent a lot of time trying to build infrastructure that enables developers to build useful applications, to use blockchains and smart contracts to build other applications other than what the blockchains themselves do, right? And the thing that I'd be really interested to hear, and I'm sure you guys have a kind of unique perspective on, is what are the missing pieces that you feel are limiting developers right now, that if we could wake up tomorrow and developers had this feature, this capability, that capability, it would lead to a very large increase in the applications that that they can build, right? Like from my point of view, at least my list would be oracles and the ability to connect to data, privacy, because contract privacy determines whether a lot of contracts go on chain, and then third place for me would be scalability. But that's kind of my simple initial list. I'd be thrilled to hear what is the dream wish list of capabilities that you think if developers had this today, it would take our space to a whole new level of kind of value creation. Okay, sure. Jay?
I'm just going to double down on IBC. I think it's funny, but I think it's really important. Like for years, people have been trying to figure out how to scale blockchain systems, and here's a very simple way with very few assumptions to allow that to happen. And that changes the way they think about how to design these systems, including taxes, like I mentioned earlier. So I think once IBC's out, people are going to start shifting the way they think about how to design blockchain systems, not only in terms of like how they code it, but also like how they set it.
Other items that are important are user experience and security. And that includes user experience and security of wallets. It also includes things like the blockchain having fast and reliable confirmation time. It includes security of smart contracts.
And I think today for developers, for the developers who are now building blockchain applications, just traditional applications, there are so many toolings to make their life so much easier. When you deploy something in the cloud, it's so much easier. I think blockchain is it's a very new domain for developers, and of course there's a lot of there hasn't been so much time in building out the tool support and everything. So I think that also makes a big difference. But I very much agree with you. The earlier list, I think, first from the infrastructure perspective, really we need greater scalability and privacy protection, as we already talked about. I think these are really
Right, so you think it just takes more time for developers to get educated about blockchain?
It's not just being educated, but also really having the tool support to make it easy for them.
Just all the tooling to go, to get something built quickly.
Here's another one. Good lifeline protocols. So right now, every computer that is not powerful enough to run a phone load basically doesn't trust the server, and that's going on right now.
So you mean there's a certain kind of risk if everybody uses some kind of more centralized service, or?
Yeah, and I think there is a risk if everyone basically uses a wallet that relies on some centralized operator providing values. And if you have a lifeline that can verify blockchain consensus, then you would basically get a much stronger security guarantee, and you would not need to depend on central operators.
Yeah, I've always kind of wondered about this dynamic myself, because we have this dynamic in our space where we espouse decentralization as a way to create highly reliable agreements and high reliable ownership and all these highly censorship resistant and all kinds of other great property systems. And then we aggregate our private keys in some centralized service, or all the infrastructure runs off of some provider that made it easy for developers. And I just wonder if that dynamic would persist once more value was at stake. Is there a point at which ease of use is no longer something people are willing to give security up for, right? Is there a point at which my application secures so much value that I'm going to give up the ease of use, or I'm going to give up the ease of building something in a more centralized manner for the sake of that security?
And I think we just need to work hard on improving the usability of the decentralized approaches.
I think definitely in certain cases we use that, I think makes sense, but in general, if we want to have broader use cases and broader adoption, then definitely we would need to make it easier for users to use and easier for developers to build. But I think also it's not a particular thing that will solve to make developers' life easier. But I think also one thing the whole community has been searching for, we have been seeing progress, but still a lot more needs to happen, is that we are still trying to see what are the real world applications and use cases that can help developers to gain more adoption of their own applications.
Right. So the kind of small paradox of our space is that we need to marry usability with security in some manner that is good for users, is good for developers. As the value of what our systems secure increase, we need to have high usability and high security.
I mean, also actually as a long-term security researcher, that's in some sense always the goal that's right, that we have been trying to achieve.
There's just a natural tension that's just part of
Right, to make it easier to build secure systems and also to make it easier for users to use.
Okay, yeah, I agree.
It's not unique to the blockchain space. It's essentially
Hey, talk about the hardware. Like, the thing that makes me feel like we're so far away sometimes is just the fact that everyone's relying on hardware that ultimately we can't trust because we know about all these flaws like Heartbleed and mobile phone SIM attacks and so on. Why isn't there an open source hardware mobile phone movement? Like, I think that should exist. That's when I know we're going to get serious about security. I'd love to see that.
And mentioning this, as some of you may have also known, is that we actually at Berkeley have been working on this project called Keystone, building an open source secure enclave. It's not an open source mobile phone, but actually it's a really important element in the town to support use cases like that. So instead of just, for example, Intel SGX, which people know that has a number of vulnerabilities and have been discovered in the past and also really relies on Intel. Here with Keystone, it's fully open source. We hope that the whole community can actually come together to analyze and verify the security and correctness of the secure enclave. We actually have done the open source release. You can actually download it and you can run it on FPGA as well as real hardware, like the latest RISC-V chip. And also, we are actually in collaboration with other researchers for formal verification effort as well to provide a formal to provide formal guarantees for some of these properties of the secure enclave. And again, like what Jim mentioned, ultimately, all this code that we run, we need to run somewhere, we need to run on hardware, and also having a secure hardware that provides really strong security guarantees can also enable these privacy preserving applications, privacy computing, really in a much more efficient and practical way. But the question is, how can we actually build these secure hardware that really provides strong security guarantees and also relies not on central trust, but actually a decentralized trust. So for that, we are also in the process of starting a trustworthy secure enclave alliance to actually have different entities and have the community to come together to essentially to try to accomplish this mission.
Yeah, Jay, just to give you my 2 cents, I've actually looked into these hardware questions, and that's super interesting. It's just a lot of it's super capital intensive.
How much would it cost though? For example, to create a new open source phone.
I think there's a difference between the research dynamic and then there's like the dynamic of the manufacturing, and there's just traditionally the capex is getting lower, but part of the reason there isn't a lot of stuff in like open source secure hardware is that even if you get past the research phase, you arrive at like the manufacturing costs, which are not the same as the costs of like let's get 3 development friends and code up an MVP and get it on chain, right? But it's getting better.
Yeah, so actually we looked into this in the process of also looking at the tape-out, the Keystone. Right.
Yeah, it's.
And so actually in our case, it's not that prohibitively expensive. Actually,
it's getting better.
A few millions actually we can already tape out the chip with the Keystone secure enclave, and we are actually looking into.
Yeah, I think that's just the traditional reason that I've seen for these things is it's like the 2 stages. You got to write the software, but then you got to like pay a couple $1 million to make the silicon or whatever. So it's a whole other step in the process. So I think we've been talking a lot about these secure enclaves, and it's very clear Don has a very clear opinion on their value. I'd be interested to hear how other people think that trusted execution environments fit into a decentralized computational model, right? Do trusted execution environments have the capacity to add more security to decentralized computing systems? Or are they incompatible, or are they only compatible in certain specific scenarios? And I'm glad to start, like, Don obviously has a lot of great interviews, so if you talk to Don about it, he's going to have a whole bunch of good stuff. So I can start with Jay or Vitalik, or whoever prefers to go first.
Let's start. So I think that trusted execution environments are very important for a variety of reasons. One is, like, it just helps add to the security of the system that you're already running. So, like, for example, as a validator, you want to make sure you're running the right software, that it's not getting compromised. So the trust execution can help with that, just on the basics. But, in the long run, I don't know where we are today with trust execution environment hardware, but it seems plausible to me that an advanced manufacturing technique can make it such that, like, it's very expensive to extract a private key out of a piece of hardware. And if you can, master that technique to the point where you can put stake behind a private key that is running on a mass manufactured chip, then I think we have real security that's quantifiable. And I think we might see that, like, within our lifetimes.
I definitely think that trusted hardware is better as an add-on to a security systems rather than as something that you're fully relying on. Using it for proof of stake, good use case, and using it for wallets is another good use case. There's certain kinds of privacy-preserving applications where it makes sense to just wrap an extra layer of security to prevent some single party from knowing data. But in general, I definitely think you don't want to have applications where a really huge amount of value becomes vulnerable if such an execution breaks.
I think right, it very much depends on the applications and use cases. So for example, in the Oasis network, we use secure hardware, but we actually don't use it for example, for consensus. And also we don't use it for achieving integrity. And so so essentially the security and integrity of the whole system doesn't rely on secure hardware at all. Where in some cases, where for example some of the smart contracts wants to have confidentiality protection, then you can, for example, run the smart contract in a secure enclave, in a compute committee, and so on. So those essentially, again, the integrity is still protected, even if the secure hardware is broken, because we still actually use this replicated computation to ensure integrity. And then again, so on the confidentiality side, it really depends on your application's needs and the security requirements. So for example, if you want to do train machine learning models, do data analytics over data, then today's crypto-based techniques are not really sufficient. So if you want to do that in a privacy-preserving way, then essentially you need to use something like secure hardware. But if you are talking about some simple financial transactions, or if you are talking about this type of applications, then potentially then you can leverage other crypto-based techniques. So it really depends on the different applications.
Makes sense. So yeah, we've been talking a lot about all these techniques to generate privacy, zero knowledge techniques, trusted execution environment techniques, all these kind of different dynamics. If our space is able to successfully generate a very high degree of privacy on public chain environments, so environments that aren't permission, environments where people can anybody can join, do you think there's still any space for what people call private blockchains, or like these private enterprise environments? Do those environments have a reason to exist, like the permissioned environments that basically provide privacy as their primary feature? If all of these dynamics take hold, do private blockchains have a place in the future?
So first of all, I think even today, private blockchains for privacy is not really a good idea, right? Because when you talk about a private blockchain, either it's a blockchain with one node, in which case it's not a blockchain, or it's a consortium chain. If it's a consortium chain, well, it's having your data shared with only your 10 closest competitors really that much better than your data being public. So I think on any reasonable use case today, you're going to need to have some kind of privacy-preserving technology already. If you have that, then you might as well use a public chain. I think the main impediment, though, is basically scalability, right? A lot of these use cases do rely on a lot more throughput, and in some cases depends on lower latency than public chains can offer. And it definitely seems like for some time this kind of gap will continue to exist, but in the long run, the scalability of public chains will continue to improve. And I do think that even for applications that have kind of varying degrees of permissionless and privateness, some kind of connection to a public chain is a very valuable thing.
I completely agree. So just to put in different words, blockchain is meant to replicate. If you're replicating, that means you're probably not going to keep that information secure. It doesn't make sense. But maybe it's important. I want to differentiate between private and permission. So just because there are many consortiums or groups or use cases that cannot use a public chain in the sense of a publicly crypto, economically secure chain, because they require that the security is accountable to parties that they know, right? So, for example, like maybe a nation state wouldn't want to run, may not want to run on a public blockchain, but they might want to run insecure using their own validators, and run by entities that they know, right? But that wouldn't necessarily be a private chain in the sense that all the information is private. It's just, it can use the same software as public chains, but it's just a permissioned set of validators that are running it.
I think you're right. In the future, again, it really depends on the use case and requirements. But what Vitalik mentioned earlier is that in the future, for a lot of these, even in the permission setting, oftentimes they may see that it's beneficial for the permission chain to connect to the permissionless chain to, for more, in some cases you make it to share information across chains. And then in that case, yes, I think we may see more and more of this migration of this permission chain, essentially just being part of public network.
Yeah, makes sense. One of the questions that I've always had is if there's a way to bridge more private environments with more public environments through something like oracles or some mechanism that provides security around validating the private environments, data or events, and then representing those events within the base layer 1 chains, either in a privacy-preserving manner or in some manner where, because a lot of the systems that blockchains are going to need to interact with, they're not going to be other blockchain systems. They're going to be inherently private. They're not going to ever be made public. And so one of the things that at least I've always found very interesting is how do you get a private system like a data provider or some enterprise backend to properly interact with the on-chain environment. I don't know if you folks have any preferences about how you think private systems should interact with public blockchains, or how that relationship should be formalized.
Why can't they just have white coins of each other and talk to each other with Merkle branches?
Right, so you don't do it too much data on, you just kind of put small representations, is that the idea?
Yeah, you can use Merkle branches to just prove that an arbitrary event on one side happens to the other side, and then you can have programs that kind of go across the two sides, have callbacks between them and so forth.
Right, so you're taking events from one environment, representing it in the other one, having something in the middle like an oracle attest to that, and then having it attest to events back.
You don't need an oracle, right? You just need a light client of one chain to one inside the other chain. But it is full.
And then they need to kind of verify each other.
Yeah. Like it's a light client. It can verify the consensus.
Makes sense.
I'm going to walk back what I just said earlier, because I can think of a scenario where you might want a private chain. So often people want a private database, right? But once blockchain technology becomes mature enough, it will become as easy to deploy in a secure as say MySQL or existing database systems that are, say, master-slave replicated, that it's master-master replicated. So depending on your application, you might just want to use a blockchain in a private setting because it's just like a private database for use, except it's more fault-tolerant and robust. In that case, you could use like IBC to communicate about the state and reveal only the information that you want to reveal from that private chain to the public world. Right? So maybe that's one way to do it.
Got it. Makes sense. Yeah. So one of the other kind of recent developments in our space is that we've seen larger companies like Facebook start to take a role in, providing or seeking to provide certain capabilities that have been provided traditionally by, basically crypto companies or blockchain-focused companies, starting with payments and maybe expanding into smart contracts and other things. So I'm just curious to hear what everybody thinks about larger companies trying to form consortiums, not around specific contract types, but around, let's build an infrastructure that is, built by a large technology company, rather than some kind of blockchain crypto project. Like for me, on the one hand, it looks like a positive, but on the other hand, it creates a commercial aspect and a centralization risk aspect that doesn't seem like it might work out in the long term.
You talked about Libra.
Yeah. So like Facebook's Libra, that's an example. So like a large technology company trying to build these systems that traditionally have been built by open source crypto projects and blockchain teams, that type of thing.
So I think that's a very salient question. I think to answer that, the way I think about it, it's like there's so much ethics and systemic things that you need to consider when designing a currency. And given today's economic and political landscape, if we don't check things like Libra, which is essentially trying to become it will be trying to become a dominant currency if left unchecked, run by a consortium of companies. But is that what we need in terms of a currency? I don't think so, because the biggest power that something like a government has is the ability to issue fiat or coins in order to pay for the common good. That's what's happening today, and I think that's what's continue to need to happen in all levels of our association. And so, to yield that to a consortium of international companies would be extremely dangerous. So I'm really glad that there's a lot of regulatory checks happening, and I think going forward we're going to see more progress, but I think we'll see more progress that are led actually by governments and those kinds of entities rather than consortiums of companies, at least in terms of currencies.
Launching a new blockchain is hard. Launching a new currency is also hard. So launching both at the same time is like hard squared. So I definitely expect a lot of different people to be trying different combinations of this sort of thing. Which one will succeed? I have no ideas.
I think the exciting aspect is the user base. Goes without saying. I think we have already seen, there are a number of examples where, like you mentioned, big companies are companies with a lot of users. They are actually entering the space, And I think that is going to be exciting for the space to help more users to essentially to be exposed to the concept, even though it may not be, there are different versions of different types of blockchain technologies and to what degree the decentralization is and so on. But I think one thing is in the blockchain space, a lot of the networks are essentially need to spend a lot of effort trying to gain users and so on. And the advantage of these companies is that they already come with such huge user base. And it'll be exciting, I think, to see what comes after that.
Yeah. I care about this problem a lot, especially with regards to Libra. And the big question in my mind is, what is the responsible thing that we should be doing as creators of the next financial infrastructure in order to ensure that we can not only prevent systemic risk, but also solve major problems like climate change and so on. So if anyone has any idea and wants to contribute to that kind of thinking, then please contact us, because that's what I do when I wake up in the morning.
Great. Well, thank you so much for all the panelists for sharing their thoughtful, candid points of view on all this. It's been very interesting for me, and thank you very much.